We had Scatterplot Day 3, our major focus on line of best fit and how to use those lines of best fit. So we're going to make two lines of best fit, one from a pre-drawn line, one where we're going to make it ourselves, and then with our third problem, we're going to make our line of best fit, and then we're going to answer some questions using our graph and line of best fit. So here's our first scatter plot. What we can see right away with this scatter plot is that we have a negative correlation. It's decreasing from left to right. And I'm going to grab the information. I'm going to grab these two dots that we use to make our line of best fit. So the first one's at 0, 7. This one's at 7, 3. So those are our two dots right there. We're going to find the slope between these two dots. Remember, that's the rise over the run. So from 7 to 3, it fell 4, so negative 4. You can see that over here as well, 1, 2, 3, 4. And then from 0 to 7, that's 7. It ran 7 spaces, so 1, 2, 3, 4, 5, 6, 7. Identical, we have to make sure that our scaling matches with it, because there's a few graphs where each one of these boxes are actually going by 2s instead of 1s. So we don't want to rely on the graph, we want to rely on the table. And we see negative 4 over 7. So far our line of best fit says this. I'm now going to add in our y-intercept. Y-intercept is where the line crosses the y-axis. Crosses right there at positive 7. The only thing I'm going to do is I'm going to convert this fraction into a decimal. So I'm going to grab my calculator here. Let it load up. Yep, I'm on the trial version. Cool. All right, there we go. Clear out, that's for my last class. So I'm going to take that negative 4, I'm going to divide it by 7. 2 decimal places. So this 7, we're going to look at the 1, tells us to keep the 7. So we have negative 0.57x plus 7. There's our equation of line of best fit. If we have a scatter plot where after we've plotted all the points we haven't drawn this line of best fit, we're going to draw it ourselves. So we're going to look for 2 points that we can draw a line through that will represent the flow of the data. What I kind of like to start with is either using a ruler if I'm on paper, but I'm going to put this straight line right where I think that line should be. I think this green line of mine represents the flow of the data. It goes right through the center. And so what I'm going to do is I'm going to, once I have this line here, on a computer I can manipulate it back and forth wherever I want. But if I truly think that this is the right flow of the points, then I can kind of tweak it just a little bit to go through 2 of the dots on the graph. So I think this dot and this dot do a pretty good job of representing. I'm going to count to make sure I've got equal number of points above and below. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 9 up here, 10 down here, roughly equal. That's good. We don't want to just rely on the number of points above and below, and we don't want to just rely on the line flowing with our points. Because I could argue that this line right, I think right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I were to use these two dots, that evenly splits the dots left and right, but that line definitely doesn't flow with the data. Just as much as this line flows with the data, because it's almost identical to that one, but we don't have equal number of points above and below until we put it here. We want best of both worlds when we pick our line. It could take some chances for guess and check. So now that I have my 2 points, I'm going to record them in a table. So I've got 2, 3, and I've got, well, let's say it's 10, 6. Find our slope. 3 on this side, 8 on this side. So our slope is 3/8. And our y-intercept is a little bit above 2, so I'm going to say that's a 2.1. So our equation of our line is 3/8x plus 2.1. I'm going to grab the calculator. We're just going to estimate 3 divided by 8. .375. We're going to keep 2 decimal places. So 0.38x plus 2.1. There's our equation. On this last one, I've pre-plotted the points. What I had to do was I had to figure out the largest number that my x column got to. That way my scale got there. So I had 17 boxes. I was able to go by ones. But my largest y value was 60. So I had to go by 2s on my y-axis over here. I'm going to label this minutes. This one over here, jelly beans. So I don't know what you're doing up here now. Bring that down there, perfect. So a few questions that we had with this one in class. What correlation do we see? We see a positive correlation because it's rising from left to right. If I had to explain that correlation, what I would say is as minutes goes up, so as they increase, jelly beans goes up or increases. I'm going to draw my line of best fit. So first thing I'm going to do, since I'm on the computer, I'm going to draw a line that I think fits the data. So I think that's where I draw my line. If I was on paper, what I would do is I would turn a ruler on its edge. So I should have I would turn a ruler on its edge. Oops. And I would lay that ruler, oh man, I'm just going to get rid of this ruler. There's lag in my system here. Oh my goodness. Go away, ruler. There's more trouble than you're worth. And I would lay it on its edge, and that ruler would represent this line. Now I want to make sure I go through 2 points that kind of fit the same flow, so I'm just going to slightly modify it right there. So my 2 points that I would have picked, this point right there, this point right there. That is 2, 9. and 1241. All right, line of best fit. So first thing I do is find my slope. So from 9 to 41, that is 32. From 2 to 12, that's 10. So that's 32 over 10. So my slope is 3.2x. What we have to do now is find our y-intercept point right there. That's a little bit above 2, a little bit below 4, so I'm going to estimate it perfectly at 3. So there's our equation of our line of best fit. We're going to use that on our questions here. So now that we have a scatter plot, now we have the line, we can actually use it to answer questions. So we're going to start with this left column over here. If 24 jelly beans were eaten, what is the estimated time? So because we're asking about jelly beans right here, I'm going to come back to my graph real quick, and I see that minutes goes with X, jelly beans goes with Y. So I'm going to find 24 jelly beans over here on Y, so it's right here. I'm going to go straight across. I run into my line of best fit right there. Come straight down. So how many minutes is 24 jelly beans? I'm going to say it's about 7. About 7 minutes. If 11 jelly beans were eaten, so we come back over here, so 11 jelly beans, it's right about, so here's 10, 12, so 11's here. Straight across, straight down, say maybe 2.5. About 2.5 minutes. If 75 jelly beans were eaten, so I come back over here, I find 75. Uh-oh. 75 isn't on our graph. So unfortunately, we can't use the graph to estimate 75. We have to use the equation. That equation we had was 3.2x plus 3. And here's the importance of identifying which one's x and which one is y. So jelly beans was y. So we're going to take this 75 right there and we're going to replace y. We solve this equation, we subtract 3 from both sides. We get 72 equals 3.2x. Divide by 3.2. And x equals, bring up the calculator here. Oh, 72 divided by 3.2. We get 22.5. 22.5 minutes. Notice that x here represents minutes, just how x represented minutes here. This other column of questions is the same kind of process, but now we're focused in on the x's all the way through. So at 12 on the x-axis, 12 minutes. So there's 12 minutes. Come straight up. We're at 41. Jelly beans. At 3 minutes, so here's 3, we go up this time and then across, we're at 12. About 12 jelly beans. At 30 minutes, so over here, 30 is not on our graph, so we're not able to estimate using our graph. So again, we turn our attention to the equation, but we're going to put this 30 into the x right here. Y equals 3.2 quantity times 30 plus 3. Grab our calculator. 3.2 times 30 plus 3. And we get 99. Y equals 99. 99 what in this problem? Jelly beans.